Welcome to Regis Algebra 2, Lesson 11B. We're beginning a new chapter now, and as we started discussing in class, this is on rational expressions and equations. That means rational, those that can be written as ratios. In other words, this whole unit's going to be on fractions. First, we'll talk about how to simplify fractions. We'll talk about how to add fractions. We'll talk about how to subtract fractions, multiply fractions, divide fractions, work with complex fractions. Same kinds of things you've done before, but now the original scenario you're working with is going to be much more complex. It's going to be these polynomial expressions. But you can do this, okay? You just got to, don't get afraid of it. Now, the first idea has to do with manipulating signs. And we want to, in particular, simplify signs. Now, he starts off by giving us several rules. We really shouldn't have to talk about this, but if we have a negative a over a negative b, that is going to be a positive, because a negative divided by a negative is positive. That's the same as that. Or it's the same, we could also write it as a positive in front, if we need to, and we might need to, depending on what we're thinking about. If we had a positive a over a positive b, of course, that could also be written as a positive in front of the term. If we have a negative a over a positive b, we only have one negative. A negative divided by a positive is a negative, and so we could write that in front. So we could either write it with the numerator or in front. And finally, if we had a positive over a positive divided by a negative is a negative. And so we're, in these cases here, we're pulling the sign before the fraction. Or we could also take this, if we want to look in this direction, we're drawing the sign up to the numerator or down to the denominator, if I'm going from this side to this side. Here, in this case, the last problem, we're drawing it down to the denominator, we're drawing it up to the numerator. We are drawing the plus sign to both. That would hardly make sense, but that's all right. Or in this last case in particular, it really doesn't make sense to go, I would not automatically go to negative signs over there. So these are a little bit more obscure when we're going from right to left. But what are you supposed to do with that information? Well, we want to simplify, okay? So if I had a negative 2 over a negative 7, I've got a negative divided by a negative. That is the very same as 2 7s. If I had let's work with some variables now. If I had a x plus y over a negative x, I could draw, that's a positive expression, over a negative expression. I could draw that positive divided by negative is a negative. I could draw that negative sign out in front. And these two are equivalent expressions. Let's see, some more. If I had something like notice I have this negative sign out front. If I had a plus, let's do minus here. If you get a negative sign in front of both terms, remember, that's the same as drawing that negative sign forward. And so I could rewrite this as negative x plus y in the numerator over a negative a plus b in the denominator. Hopefully, you've learned from previous times that that's how that works. Combining these two negatives, I would get x plus y over a plus b. So learn to see when a negative's in both terms like that, learn to see it as one negative sign dropped out, pulled out, and leaving you with a plus b. So now if I have a problem like, let's say, I'm seeing this as one negative sign pulled forward. This is one negative sign pulled forward. The negatives will cancel out, and that should be equal to x plus y over a plus b. Okay, I'm taking less steps, but I want you to really learn to just see this visually, okay? If I see I've got pull out a negative there, and that will be the same as negative a plus b over x plus y. So you work with those. It's only 1 through 8, and make sure that it's very simple to you. If it's not simple, if you can't see this visually, so that you don't have to even write any intermediary steps, then ask me when you get to class and we'll do some more problems, because this should be one you should just be able to visualize, okay? And if not, we need to go over the idea again. Now, 3.2 is a big section, and so let's look at this. This has to do with simplifying or reducing to lowest terms of fraction. Now, in order to do this, you must simplify the numerator, which you will have to do by factoring, simplify the denominator, which you will have to do by factoring, and then canceling. So let's take a problem. Here's my problem. First thing I'll do is try to identify a common factor. In my numerator, it will be x, leaving me with x minus y. In my denominator, it will be an x, leaving me with x plus 2. Then cancel, and you're going to get x minus y over x plus 2 as your answer. That's simplifying this. That's the same as that. Okay? Now that's really all there is to the concept. The concept itself is not hard. Factor and cancel. Okay. Of course, the factoring is the challenge. Let's try another. I recognize my numerator as a perfect square trinomial factored to a minus b squared, or I might even be more helpful to write it out this way when you're doing the simplification, because then you can cancel a little cleaner on paper without losing things. The denominator is difference of squares, which is b minus a times b plus a. And the only trick here is because this is written the opposite. This is a b minus a is almost like an a minus b if I pulled out a negative sign. So I could also write this as a minus b times a minus b, and this is being able to recognize the relationship with the negative sign, pulling out a negative sign or a negative 1 as a factor from just the first term. I would get negative b plus a. You see that? Negative b, look in here. Pulling out the negative sign, everything inside would go the opposite sign, so it'd be negative b plus a, which is the same as positive a minus b. So pause if you need to make sure you recognize that. And then I'm going to rewrite this one, because I like the a's in front and the b's I want the same order as in the numerator and denominator. So rewrite the b plus a as a plus b. Now that I've done that, I can cancel. Okay. We're going to cancel this with this, and we're going to be left with a negative in front, a minus b over a plus b. Let me make sure if that's the form they like. Yeah, they're giving it to you in 2 possible forms. I like that form. That's fine. Okay, I like it in the think variables in alphabetical order, just like that. That'll be a perfect answer. Okay. Now looking down below, let's say if we have something like x cubed y squared z to the fifth. This monomial cancellation should be familiar to you. Looking just at the x's, two of them can cancel out, and I'm left with one in the numerator. Looking at the y's, one y can cancel from the denominator to the numerator, leaving me one extra y in the numerator. Looking at the z's, it leaves me with two extra z's in the numerator and nothing in the denominator. So that kind of factoring, we call that monomial factoring, because it's just a monomial over a monomial, one term over one term, no addition and subtraction. So nothing else to do there, just common factoring. Okay, so that is several of those. Let's look at something like number 4. In 3.2, it says there's a couple of different ways to teach this or look at this, but I think maybe the easiest way is to interpret this for you. That simply means, remember when we're multiplying, like x2 times x to the third, that's the same as adding my exponents. So I'm going to reinterpret this as x to the m, x squared, y squared. My denominator is x to the m, y to the fourth. When I'm going to simplify that, then, once I've reinterpreted it, it becomes pretty easy. This, why did I get a negative up there? This cancels with this. I'll have x squared, and the y squared cancels into the y to the fourth in the denominator, leaving me with y squared in the denominator. So that would be that kind of answer. I'm looking again through for the next ones. You just want to factor and cancel. Factor and cancel all the way down. I'd like to just look at, okay, so now looking at 13, I'd like to look at that together, at least get it started together. Trouble writing. I think I'll just do 13 and let you stumble through 17, see if you can make sense out of it after watching this one. Again, I want to reinterpret this, and I want to reinterpret this, and I want to reinterpret this. Okay, let's rewrite those. That would be the same as a to the n times a to the fourth, because if we were to multiply, we'd add exponents, minus a to the n y to the fourth, all over. In the denominator, that would be the same as a to the n a cubed plus a to the n a y squared. Now, what do I have to do? I have to factor. Let me do the next step. You try to work it on your own and then compare yours with mine. So I ran out a little bit out of room, but the numerator should read a to the n times the quantity a squared plus y squared times the quantity a plus y times the quantity a minus y. And then if I cancel, those will cancel out, these will cancel out, and I'll get as my final answer a plus y times a minus y all over a. So you try to work the next one, and you should be able to do those. We'll go over any answers or troubles you have in class.